yesterday in the Unit 4 Building Block 2 notes, we got through the examples over after co-function and odd even identities, and then I asked y'all to try these check for understanding on your own at home. And then we were just starting to talk about sum and difference identities. So actually, I guess before we jump into sum and difference, we can, do y'all want to go over one of these check for understanding questions, or did y'all feel confident with all three of those? I cannot go over all three, we don't have time, but I will post the key for all three, but I'll go over one right now. Is there a certain one that's preferred? Number 3? Okay. All right, so number 3, it does say to simplify by factoring, but at this point in time, there's no factoring that can be done. So we've got to do some work before we can get to the point where we're going to factor. Okay, a pen here. We've got two fractions separated. It's the difference of two fractions. So if I'm trying to simplify, I know I'm trying to work down ideally to a single trig term. Okay, so I have to be able to combine the fractions, and to add or subtract fractions, we have to have a common denominator. When we have this situation where the two denominators have no common factor, it's not like I can change one of them to match the other. So I have to change both of them to match each other. Okay, so I'm going to multiply both fractions by the opposite denominator. So this fraction, both the numerator and denominator, are going to get multiplied by cosine. And on this side, this fraction is going to get multiplied by 1 minus sine. So in the numerator on the left, I can reduce this to a cosine squared times sine, or sine times cosine squared. I don't care what order you write that in, it doesn't matter. And then we have a minus. And then I'm going to put a parenthesis because everything that's over here when we simplify has to be subtracted. So these are actually conjugates, aren't they? These two binomials, they're almost the same except one's plus and one's minus. When you multiply these conjugates, the middle terms cancel out, don't they? Because I'm going to FOIL this out. First, outer, inner, last. The outer, 1 times negative sign, and the inner, 1 times sine, cancel each other out. So there's not going to be a middle, it's not going to be a trinomial. Okay, so I'll just have the 1 and then the minus sine squared. Okay, and then this common denominator that I created of cosine times 1 minus sine. There's actually a couple of routes you could take here from this point, because you do have a difference of squares here that some people may go that route to try and cancel this denominator. But the easier route is, hopefully, if not already, soon, this expression and expressions like it will pop out at you as what? That's a Pythagorean identity. Okay, what is that equivalent to? Cosine squared. So I'm going to replace that. I'm going to make that substitution. That's equivalent to cosine squared theta. Okay, and that's being subtracted. And we've got sine and cosine squared. Now I can factor. So when it said to simplify by factoring, now I'm to a point where I have something to factor in my numerator. What can I factor out? Cosine squared, so GCF. What does that leave me with? Okay, I'm going to go ahead and write my denominator real quick. before I write anything else. So if I factor out just the cosine squared, that's going to leave me with a positive sign minus 1, right? That's really close to this binomial, isn't it? But it's not exactly the same. What's different? The positive or negative sign, right? So to fix that, what if I factored out a negative cosine squared? That would leave me with a negative sign, and then that would become plus 1. Now, that's written backward, but that's the exact same thing, isn't it? So now I can reduce that. If you don't catch that then, and you just factor out the cosine squared, then in a second step, you can then factor out a negative from either the numerator or the denominator factor and end up with the same thing. But if you catch that and you can do it all at once, it just saves you a step. Does that make sense? Okay, so just pay attention to your positive and negatives because you're trying to get things to simplify and reduce. So now we're left with just cosine squared, negative cosine squared over cosine. Can something there reduce? Yeah, one of the cosines from the numerator, so it won't be squared anymore, can reduce with the cosine in the denominator. And that's just a 1 now. So I'm left with simply negative cosine theta. Did anybody successfully do that one? It was a tough one with the sign change. You got to pay attention to those sign changes. All right. So I will post the check for understandings for this whole notes packet. So the ones from yesterday's notes and the day before as well. So I'll get all of those posted. So the ones that we're not going over together, y'all will be able to go back and check still. All right. So the part that we didn't get to yesterday in this class was sum and difference IDs. So here they are, just listed out. If you can break an angle down into two angles that you know the values of, these sum and difference IDs come in really handy. So if it's sine of the sum or difference of two angles, this is what it expands to. Okay, sine of the first angle times cosine of the second angle, and then whatever this was, I'm going to color code this because this is a common place to make a mistake. This sign stays the same. So if it was sine of u plus v, that's going to be a plus. If it was a minus, this is going to be a minus in the expansion. Okay, and then it's cosine of the first angle times sine of the second. The difference with cosine of a sum or difference is, one, that sign actually changes. Notice I wrote it as minus over plus because you do the opposite when you expand. The other difference is that up here for sine and cosine are together, right? Sine of u, cosine of v, cosine of u, sine of v. Down here, the cosines stay together, the cosine of each angle, the product, and sine of each angle, and you do the product. And then for tangent, it actually expands to a fraction. So in the numerator, you keep the sign the same, and you're doing the sum of tangent of each of the angles. And in the denominator, you do 1 minus the product of the angles. And I say minus because you're doing the opposite sign. Feel okay about that? So we're just going to jump into some examples using these. There's different types of questions where these could come into play. So the first type is if you're asked to evaluate a trig expression for an angle that's not one of the special angles that you know. So when we learned the unit circle, when we memorized all of those points, we memorized pi sixths, pi fourths, pi thirds, pi halves. We didn't memorize pi twelfths. Okay, but I could rewrite pi twelfths as a sum or difference of two angles that I do know. and then use that identity to solve. So what I'm going to do first is I'm going to write out the angles that we know. Okay, so we know I said pi sixths, pi fourths, pi thirds, and pi halves. Those were the four with denominators that we learned, right? I'm going to rewrite those as twelfths so that I can see them broken down to see what could add or subtract to 1 pi 12th. So what would pi sixths be as twelfths? Okay, what would pi fourths be as twelfths? And pi thirds? Oops, started to write it as a third again. And pi halves. So is there a combination of these that you could add or subtract to come up with 1 pi 12th? You could do 3 minus 2 or 4 minus 3. Both of them would work. We're going to get the same answer no matter which ones we choose as long as we do it correctly. Y'all just want to do the first two? Okay, so I'm going to use these two angles. That's going to become that U and V. Okay, so I'm going to rewrite this as sine. And now it does matter what order I write them if it's a difference. If it's a sum, it doesn't matter. Okay, but this is a difference, so I need the 3 pi 12ths minus 2 pi 12ths. Now, I don't think in terms of twelfths when I'm thinking about my trig and my unit circle. So I'm actually going to go ahead and rewrite that as pi fourths and pi sixths, because those are the terms that I think of it in. And then I'm going to do my expansion with the formula. So the formula said that I take sine of the first angle times cosine of the second angle. And then do I put a plus or a minus here? Remember what the formula, do I keep it the same for sine or switch it? Sine, we keep the same, so it stays minus. And then you can write cosine of pi fourths or sine of pi sixths first, it doesn't matter. The formula has sine, cosine, and then cosine, sine, because it keeps the angles in the same order, UV, UV. I tend to write sine, cosine, but it doesn't matter because it doesn't, when you're finding the product, it doesn't matter what order you multiply in, right? So you can do whichever you prefer. Oh, well, you can't do the exact same angle twice. So the product of sine and cosine, sine of the first, cosine of the second, and then sine of the second, cosine of the first. Everybody cool with that? That's from the formula. Now I have to know my unit circle. I know it's been a while since we've used it. You had the whole winter break off, and so you may need a little bit of a refresher. If you need to go back and use some of those links to resources in the past unit folders to kind of refresh, you can. Okay, but what is, I'm going to just draw a picture as a refresher here. There is pi fourths. Okay, what's that ordered pair at pi fourths? Okay. Okay, and here is pi sixths. What is that ordered pair? Good. Now, which is sine and which is cosine? Sine is y, cosine is x. So when we say sine at pi fourths, that's this one. When I say sine at pi sixths, that's this one. I'm just picking random colors, sorry. You don't have to highlight, I'm just trying to do this for our notes. So cosine at pi sixths and cosine at pi fourths. Everybody good with what I'm going to do? So I'm going to go ahead and put those values in because I know those values. So that's root 2 over 2 times root 3 over 2. And that's 1/2 times root 2 over 2. And then I'm going to simplify. When you multiply radicals that are not the exact same radical, what do? Can you do that? How do I do it? Yeah, you multiply what's under the radical and it stays under the radical, right? So it's the square root of 6. And it's over 2, or excuse me, over 4, because we were multiplying, minus, and then over here, my denominator is going to become a 4 also. And when I multiply that, that's just root 2. Now, it's nice that I have a common denominator. I could go ahead and combine these fractions, but can I combine the radicals with addition or subtraction? No, I can't do what I just did for multiplication. That's not the same, okay? Square root of 6 is a different number than square root of 2. It's not like combining like terms. So I just leave it as square root of 6 minus square root of 2, but I can put it all together over 4 as one fraction. And that's as far as we need to simplify it, as we need to take it. Good? Okay. Yeah. Okay. Another instance is working in reverse of that, which is actually easier. Okay, so going in reverse, it's already in the expanded form. So we just need to recognize what identity this is. Is this sine, cosine, or tangent sum or difference? Because notice the cosines are paired together and the sines are paired together. So this must be cosine. So I know it's cosine and it's the opposite, right? So this is actually going to become a plus. So this is the cosine sum formula. Okay, and then my two angles, yeah, go ahead. You can refer back to the formulas. We're just looking. So in sine, the sines and cosines are mixed. They're being multiplied by each other. And with cosines, cosine stays together, sine stays together. And remember, you don't have these are not ones that you're going to have to memorize. You'll have them on a formula chart. So my two angles are 25 and 15. Okay, and so then I can go ahead and add those. I should put the degrees. Because that's in the formula for cosine, it's the opposite. So the cosine sum identity, the expanded version has a minus. The cosine difference, the expanded version will have a plus. Yes. And that's it. So that was a lot easier. That one was just asking us to simplify using the identity. Now, if this angle had simplified to an angle, one of the special angles that we know, like if that had simplified to 30 or 45 or 60 or 90 or something, we would go ahead and give the answer. We would evaluate it. But we don't know cosine of 40 off the top of our head. So we'll just stop there. Good? Okay. All right. The last type of problem that you may see is asking us, this is verifying. So this is going back to what we were doing. Like we want to prove the left side does equal the right side. So remember, we're only going to work on one side until we get it to match the right side or the other side. Okay, so here, this is a cosine difference identity that I can use. One of the angles is x, one of the angles is 3 pi halves. So what is this going to be if I use the cosine difference identity? What would I write this as? cosine of x, cosine of 3 pi halves, plus, good, it's going to be the opposite sign, sine x times sine 3 pi halves. Good. Refresher again, you may not have to put this on your notes, maybe you'll know it. And I drew that x-axis in the wrong spot. 3 pi halves, that's right here. What's the ordered pair? Zero, negative 1. Okay. So that is cosine at 3 pi halves. That is sine at 3 pi halves. If I multiply by 0, what do I have? Do I have to write 0? No, this is just gone. It's a 0. It doesn't exist anymore. And then what am I left with over here? Just negative sine of x. And is that what I was trying to prove? Yep, I've proved it. I verified those are indeed equal. Y'all okay about those? Okay, so you're going to have, there's 3 check for understandings that kind of correlate to those examples that we did that I want y'all to try today or tomorrow, and we can go over some questions for those. All right, so that's the end of that building block 2, or that part 2 of these notes. And so we're going to jump ahead then to the next page. I'm recording right now. I'm going to stop this video and I'll start a new video for the next part.